This house was supposed to be demolished. It sat on a corner in San Jacinto County, Texas, a yellow Victorian farmhouse, more than a century old, with the kind of scale and porch front presence that you cannot fake. The land had been sold for a gas station. The new owner planned to clear the site. The house, the surrounding buildings, and the elevated water tank beside it were all marked for removal. Most buildings die this way. Quietly, a sale closes, a machine arrives, a house with 100 years of local memory becomes debris in a few hours. This one did not. I was working in San Jacinto County, just north of Houston, helping a client develop rural properties as part of a long-term placemaking project. The job was part planning, part construction management, and part salvage. The goal was not to drop new buildings onto the land as if nothing had come before. The goal was to root the work in local history and local memory. So, between job sites, I kept noticing this house. It had the proportions, the roof line, the porch, and the local character my client wanted for a wedding venue. It was not just old, it had presence. I contacted the property owner, Surinder Singh, and made a proposal. Let us take this house and water tank at our expense, as long as we could remove them within his construction schedule, and he agreed. So the house was practically free. That's of course the misleading part. The house itself cost almost nothing. The expensive part was everything required to keep it from being crushed, hauled away, and forgotten. After asking around, we were referred to L.W. Oney House Moving, a fourth-generation company that moves buildings most people would never imagine moving. They do not just relocate structures, they manufacture much of the equipment needed to do it: hydraulic trailers, air ride dollies, unified jacking systems, and custom rigs built for each load and route. This house weighed about 180,000 pounds. It stood more than 30 feet tall. From an engineering standpoint, getting permits from TxDOT was not the hard part. The route was the hard part. The house had to move about 3 miles. Along that route were power lines. Local utilities estimated that lowering, removing, and reinstalling lines would cost nearly $500,000. By then, money had already been spent lifting the house off its original foundation. If we stopped, the money was gone, and the house was still lost. That's when Lonnie Oney stepped up and made a suggestion. Cut the house in two. Move the top half first, move the bottom half second, then put the house back together. It sounds unreasonable until you see the equipment and the crew. The change order added about $125,000 to a move that was already expected to cost about $120,000, so double the price. But my client agreed. Rebuilding something vaguely similar would have been cheaper, but this was not about creating a cheap replica. It was about preserving the real thing. Before the house could move, the site had to be opened up. Trees were cut, brushes, fences, and other obstacles removed. The movers needed a runway from house to the road. House-moving dollies are powerful, but they are not off-road machines. They can handle gentle slopes. They cannot cross ditches, sharp drops, or steep grades with 180,000 pounds balanced above. Utilities were disconnected, plumbing was cut. My HVAC subcontractor removed condensers and ductwork that would have blocked the beams. Then an 18-wheeler arrived with steel. The crew threaded large I-beams through the house footprint, perpendicular to the floor framing. The beams were extended beyond the walls so the lifting systems could reach them. Longer beams ran lengthwise, forming a steel chassis beneath the house. The chimney was the problem. There were 2 fireplaces, one above the other, rising through the center of the house. Heavy masonry, right in the worst possible location. One mover told me the chimney and fireplaces would have to go before the house could be lifted. The Oney family had a different answer. They moved the chimney too. Kyle Oney, Lonnie's son, who managed the lift on site, said the chimney was the toughest part. It was heavy. It had deteriorated mortar joints. It concentrated weight in the middle of a structure whose foundation was about to disappear. So Kyle built a steel crib with a plywood pan directly under the chimney stack. He tied it into the adjacent beams to keep the fragile masonry from cracking during the lift. It took nearly a week before the undercarriage was ready. The crew checked every part of the house to make sure nothing was unsupported. The lift was done with unified hydraulic jacking machines. That matters. A house like this cannot be lifted casually. One jack may be under a light porch corner, another may be under the chimney. The loads are not the same. Kyle explained it this way. A porch corner may take 180 pounds. The chimney might need 1,400. Each jack provides the pressure required for its own load, but the house still rises evenly. That is the point. If one side rises faster than the other, the house can tear apart. So the crew lifted slowly. In a sped-up video, it looks dramatic. In real time, it was slow, careful work. Gauge readings, small adjustments, cribbing added, no jolts, no cracking, no one side of the house allowed to get ahead of the other. At full lift, the house rested on cribbing towers made from 6x6 timber stacked just like oversized children's blocks. Then Lonnie texted me. "We have liftoff," he said. The house was free of its original foundation. Now came the dangerous part. The house was balloon framed. That means the wall studs ran continuously from foundation to roof. There is no horizontal platform between the first and second floors the way there is in most modern framing. So, before the crew could cut a house apart, they had to create a new temporary structure at the cut line. They removed a 4-foot strip of drywall around the entire second floor. They built a temporary frame of 2x6 lumber, face-nailed along the separation line. Steel beams were threaded through the house beneath that temporary frame and extended onto the 4 tall steel lifting towers. Once everything was supported, the crew cut through the studs at the midpoint of the house. The upper half was now free and lifted. The lower half rolled out from underneath it. From inside the lower section, the first floor ceiling of the upper half drifted overhead. Ceiling fans hung about 16 feet in the air and turned slowly in the breeze. It was strange to watch. Not glamorous, not clean, just timber, plaster, steel, hydraulics, and an old house being asked to do something it was never designed to do. At that point, speed mattered. The lower half now had no roof, and it was threatening rain. The upper half went first. Workers in safety harnesses climbed the steel frames and made final adjustments as the hydraulics balanced the load. They called measurements back and forth. Driver's side, level. Passenger side, down 1/2 inch. Then the upper half settled onto its own rig, fitted with multi-directional dollies. The house moved at about 3 to 5 miles an hour. It traveled 3 miles down rural roads, escorted by wide load vehicles with flashing lights and followed by a line of frustrated and fascinated drivers. Lonnie pulled from the front. Kyle controlled the rear dollies with a radio link controller. Each dolly could steer. Each could raise or lower hydraulically. The air ride system absorbed shock from the road so the framing would not fracture from vibration. Kyle said something that explains the whole job. "We're not moving houses, we're moving weight. You walk it, you watch it, you correct constantly." At the destination, another set of steel towers was already waiting. The upper house was lifted back into the air. Then the lower section made the same trip and was backed beneath it. That sounds simple. It was not. The lower half had to slide under the suspended upper half in a line, stud over stud. Not close, not generally close, exact. Crew members stood inside the house on the towers calling corrections. Driver's side, 1 inch, passenger side, 1/2 inch down. The dollies responded in tiny increments. The house shifted, the gap narrowed. Eventually, the studs lined up. Kyle said, "It seems impossible to set stud over stud, but it is hydraulics and patience." Once the alignment was right, the upper half came down onto the lower half. The crew permanently locked the studs together with 2x4 splice members screwed along both sides of the studs, extending about 2 feet above and below the cut. These were not temporary cleats. They became part of the wall system. The house was whole again. Now the reunited house had to be lifted again about 6 feet above grade. People often ask, why wasn't the foundation built first? The answer is practical. You cannot easily drive a house-moving rig over a finished foundation without, well, damaging it. With an old house, the building itself is often more accurate than the drawing, so the house dictated the foundation. With the house up in the air, comfortably 6 feet above, plumb lines were dropped from the sills and bearing walls down to the soil. The crew traced the footprint of the suspended building directly onto the ground. Instead of building from drawings and hoping the old frame landed perfectly, they laid out the foundation from the house itself. David Wilson, one of Oney's senior foremen, led the foundation crew. They built a continuous T-shaped footing around the perimeter and placed interior post footings to match the original bearing points. Forms were set, concrete was poured. All of it happened beneath a 180,000-pound house suspended in midair. While the footings were curing, the exposed underside of the house became accessible. That's a rare opportunity. Michael Wisner of Premier Foundations of Texas put it plainly, when the house is in the air, you fix what needs fixing. His crew replaced rotten girders and damaged joists. They repaired deterioration caused by a century of moisture and pests. And that work matters. A move is not just transportation, it's also a chance to correct structural problems before the house bears on its new foundation. Once the repairs were complete and the concrete cured, masons laid CMU block around the perimeter and built interior piers under the bearing points. Again, the geometry came from the house itself. The house dictated the foundation. Now, lowering the house was not just a drop. It came down the way it went up, slowly, evenly, under control. The jacks stayed in place, cribbing was removed in stages, pressure was released through the unified hydraulic system, steel beams descended toward pockets left open in the block. There was no single dramatic moment, just 180,000 pounds shifting from steel and hydraulics back onto wood and masonry. When the pressure was finally released, the move was finished. No applause, no ribbon cutting, just a house standing where it had never stood before. The jacks were disconnected, the steel beams slid free, the cribbing came apart, and what remained was a century-old Victorian sitting on a new foundation, still itself. Kylie told me something I'll never forget. He said, "We're in the ultimate recycling business." He's right. Demolition would have sent 180,000 pounds of embodied history to a landfill. Replacing this house with new lumber, bricks, siding, finishes, and labor would have required more raw material, more transportation, and a lot more energy than the diesel burned during a 3-mile move. But the environmental argument is only part of it. There are houses like this all over the country, good timber, sound bones, workable proportions. They are not always threatened because they are falling. They are threatened because development moves faster than memory. Some can be moved, some can be adapted. Some can stand again if someone chooses reuse over erasure. The farmhouse will now be restored as a wedding venue rooted in the local character that first drew our attention. The exterior will be repaired, mechanical systems will be reconnected, finishes will be restored, utilities, windows, and HVAC will be modernized. The water tank that once served the house will rise again as a sculpture. A 30-foot-tall, 180,000-pound Victorian was lifted, divided, moved 3 miles, reassembled, and lowered onto new concrete without surrendering its identity. Steel hydraulics made the move possible. Patience made it exact. And a house marked for demolition now stands ready for another century. Subscribe for more stories about building, saving, and rebuilding places that still matter.